Hello and welcome to all students in this my YouTube channel. Students, we are in the topic of chemical kinetics, and in our today's lecture we will start this chapter. And students, this will carry for 5 or 6 marks for your theory examinations. And students, this is a very important chapter for NEET, JEE as well as MST CET. Now students, we will learn first of all the introduction about this chapter. So in chemical kinetics, first of all we should learn what is meant by chemical kinetics. Students, to understand this term we should learn the basic concepts related to it. The branch of chemistry which deals with the study of reaction rates and their mechanisms, such a branch we are calling it as a chemical kinetics. And besides this, we already learned the thermodynamics chapter. What it tells us? That chapter, it tells only about the feasibility of a reaction, whereas this chapter, that is chemical kinetics, tells us about the rate of a reaction. Means in thermodynamics, suppose if we consider a particular reaction, all the reaction conditions means like a temperature, pressure, that information can be given by that area, that is thermodynamics. Means at what temperature or pressure that corresponding reaction will happens. In that study we did in the thermodynamics chapter already. But this chemical kinetics chapter tells us about the rate of a reaction. Means at what speed that reaction gets now going to be completed, and which are the different conditions which are required for the completion of that reaction within the time, that tells us the chemical kinetics chapter. Now students, if we took a one of the example for understand this concept, thermodynamic data indicate that diamond shall convert to graphite, but in reality the conversion rate is so slow that the change is not perceptible at all. This is a good example to understand whether the thermodynamic data as well as kinetics data is very important. Now students, kinetic studies not only helps us to determine the speed of a speed, or we can say the rate of a chemical reaction, but also describes the conditions by which the reaction rates can be altered. Means it will not only gives us the information that speed, or we can say the rate of chemical reaction, but also it will tells us the conditions at which the rate of reaction can be depend. Now the different factors such as concentration, temperature, pressure and catalyst affect the rate of a reaction. This should also we take into account, because these are the important factor which affects on the rate of a reaction. Now students, what is meant by a rate of a chemical reaction? We should understand in depth. The speed of a reaction or the rate of a reaction can be defined as the change in concentration of a reactant or product in unit time, and it can be expressed in terms of the rate of decrease in concentration of any one of the reactant, or the rate of increase in concentration of any one of the product. Now student, both has the same meaning. If we consider a particular reaction A plus B gives C, in that case the terms A and B which are present at the left hand side of the arrow, we are calling them as a reactants, and the C term which is present at the right hand side of the arrow, we are calling it as a product. When this reaction happens, or when this reaction goes in progress At that time, concentration of the terms A and B gets decreased, and at the same time the concentration of product gets increased. So student, when the concentration of reactants gets decreases, at the same time concentration of product goes on increasing. This is nothing but what in brief we are calling it as a rate of a chemical reaction. Now students, we can understand by taking some different examples also. In general example, if we take, that example is nothing but a small a and the capital A. Now small terms and capital terms in the given reaction are nothing but the all the capital terms, they are nothing but the particular reactant A means capital A and capital B are nothing but the reactant species, and the capital C, capital D are nothing but the product species. And the small terms which are present in front of them are, they indicates the coefficients which are present in the corresponding chemical reactions. Now students, for such a reactions, if you want to write its corresponding rate law, then we can also write like this: minus 1 upon A into dA by dt. Student, I will first of all explain what is meant by these terms. I have already told small terms are nothing but their corresponding coefficients, and the capital terms are nothing but the reactants or products. So I will write first of all individual rate law for the above reaction. dA by dt, in front of it we have to the minus sign. What it indicates? The concentration of reactants when the reaction is in progress goes on decreasing. So to indicate that, we have taken the minus sign in front of dA by dt, and the inverse of that corresponding term which equals in the all corresponding terms, means we have taken it for to show the equality in the all the corresponding terms. So the rate law for the above reaction is nothing but minus 1 upon A dA by dt is equal to minus 1 upon B dB by dt is equal to, now the product terms are arrived. So here we are using, instead of minus sign, plus sign, plus 1 upon C dC by dt is equal to plus 1 upon D dd by dt. So this is nothing but what we can say, the concentration of that corresponding species with respect to change in time, and that is nothing but what we can say, the rate. Now students, rate with concentration we can write like this: rate is directly proportional to the concentration of that corresponding species raised to the power its corresponding coefficients. Now students, the rate for the above reaction will be like this. Instead of that proportionality sign, we have used here the K term, which is we are calling it as a proportionality constant. So here rate is equal to K into concentration of A raised to X, concentration of B raised to Y. Now students, the corresponding order of the reaction we can write like this: X plus Y. The addition of these both the terms will gives us the order of the reaction. Now here also students, we have used that terms rate is equal to K A raised to X B raised to Y. So we can write its corresponding order. Students, to write the order of a particular reaction, we should introduce, or we already introduced the term, the universal term we are calling it as a, by which, by substituting the corresponding order of that reaction, whether it is first order, second order or nth order, once we are going to substitute the corresponding value of n here. Suppose if for a first order reaction, if you substitute the value of n is equal to 1, then we will get its corresponding unit for the corresponding order of reaction. Suppose for first order reaction we have substituted the value of n in the in general equation, then we are getting its corresponding units. For second order also we have determined the units of rate constant. So in general we can say that for zero order reaction the units of rate constant are nothing but mole per liter per second, and for first order reaction per second, and for second order reaction mole per mole liter second raised to minus 1. So students, we will understand some basic concepts of the rate of a chemical reaction. Consider a hypothetical reaction, that is in general R gives P. What it indicates, reactants are now going to convert into the product, assuming that the volume of the system will remains constant. 1 mole of a reactant R produces 1 mole of a product P. If concentration of R1 and concentration of P1 are the concentrations of reactant and respectively the products at time T1, and at the same time if we calculated the concentrations of reactant and product at time T2, then we can say that the change in time to convert that reactants into product, we have taken the two times, initial as well as the final. So we are now going to determine the change in time, which is nothing but delta T, T2 minus T1. At the same time the change in concentration of reactants also now we are going to calculate is nothing but delta concentration of R is nothing but R2 minus R1, and at the same time for products also we did the same thing. The square brackets in the above expressions are used to express the molar concentration. Now the students, we are going to learn the next concept, which is nothing but the rate of a chemical reaction. Rate of disappearance of reactant, which is nothing but the decrease in concentration of R with respect to the time, that is time taken to decrease the concentration of R, and in the form of formula we can write it like this: minus delta concentration of R divided by delta T. That minus sign indicated because the concentration of the reactant space is going to be decreased. Now at the same time we should also write the rate of appearance of product, because when the rate of reactant gets decreased, concentration of reactant get decreases, at the same time concentration of the product now going to be increases. So increasing concentration of P with respect to the time, we are going to write like this: plus delta concentration of P divided by delta T. Now students, this delta R is the negative quantity that I already explained why we have taken the minus sign there, and for product we are taking the plus sign. Now the rate of a chemical reaction, for understanding we have taken one of the example. Student, this is the one of the example for which we have taken the change in time, and we also calculated the rate of formation of that reactant product species, that is Fe2 plus. So to understand this concept we have taken this reaction, we have considered this reaction for two different times and for two different concentrations. Students, T is the initial time, that is 38.5. At time T the concentration of that Fe2 plus species is 0.0010 molar, and with the change in time the change in concentration of that corresponding Fe2 plus ion will be its corresponding final minus initial values. Now if you want to write the rate of formation of Fe2 plus, we are using the previous formula that is rate of formation of product is nothing but delta concentration of that corresponding species divided by change in time. So by using that formula we have calculated the rate of formation of the product species, that is Fe2 plus IN, and its value becomes 2.6 multiplied by 10 raised to minus 5 mole per second. Now students, rates of a chemical reaction for SN4 plus species is equal to the 1/2 of Fe2 plus, that is we have formulated here for three different factors, that is ions, that is Fe3 plus also. Students, general rate of a reaction, if you want to write, which is nothing, rate of reaction which is nothing but the rate of disappearance of corresponding reactants. Students, if we look at this equation number 1, both the terms capital A and capital B in the previous slide we have already seen, they indicates the reactant species, and the rate of reactant species, the concentration of their corresponding terms with respect to the change in time, which is nothing but the rate of disappearance of reactants, and which is equal to the rate of appearance of products. So students, both these equations becomes equal. So equation 1 and equation 2 we are going to write together by combining these two equations. So you will get this one, which indicates the rate of disappearance of reactants are now equal to the rate of appearance of the products. So students, this is the very important concept we should understand in the introduction of this chapter. In our next lecture we are going to learn the average rate and the instantaneous rates. So this is all about in our today's lecture. Thank you very much.